Hi everyone, this video is on the transformation of functions. So before we begin, we just need to talk about the four functions that you should be very familiar with. The ones that you should know off the top of your head, which are x cubed, x squared, absolute value of x, and the square root of x. You should know these general shapes, and also you should know a table of values for them. The key points, if you will. So we have -2 is -8 for a cubic, -1 is -1, 0, 0, 1 is 1, and 2, 8. Okay, you should be able to know those points right away so you can plot them. Okay, so you can use them with your transformations, with your translations, things like that. All right, so you should know each of these tables. Notice that all of them go from -2 to 2, except for this last one, the square root of x, because there is no -2. -2 doesn't have a value. And it's a lot easier to count not by ones, but to count by what's the easiest thing to take the square root of. So square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, square root of 9 is 3. Those are nice, easy numbers to take the square root of, so they give us pretty y values. So we can plot them on a grid rather than going halfway in between and dealing with all these radicals that are just not fun. Okay. The other thing that you may be noticing is why I have some of these points circled. These points are the key point, the main one, the big guy, the thing that is going to move the whole graph. You're going to focus on that point when you're doing your transformations, okay? So they're always at the origin. It's at the vertex for the quadratic, vertex for the absolute value, and it's at the end here for the square root of x, and the very center for the x, for x to the third. So know those points. Those are the points you're always going to use, okay? Now, here's just a little table summarizing all of the transformations we know. Everything over here on the left is something that's outside the function. Those deal with vertical transformations. Over here, these are things that are inside the function, right next to the x. Those are dealing with horizontal transformations. The other thing that you need to know about horizontal transformations is you do the opposite. And I'll show you a little reasoning behind that to make that easier to understand. So horizontal, you do the opposite. Here's just a quick example. We have x minus 1 quantity squared plus 2. So if we write out the transformations, we're going to go right 1, so I'm just going to do R1, and up 2. Notice I see a -1, but I'm actually going +1. I'm going right 1. So why is that? If I rewrite this equation, I can rewrite it by subtracting this +2 to the other side. So I'd have y minus 2 equals x minus 1 squared. Now this is the same graph, but notice here I'm going right 1. I need to have a +1 to get me back to 0. So +1, which is right 1. Here I need a +2 to get this side back to 0. So I'm going to go up 2. Notice in this form, we're doing the opposite with everything. So technically, we're always doing the opposite, but by moving all these things over to the other side of the equal side, by just having a y equals there, we do exactly what it shows us to. But really, we're always doing the opposite. So whenever you see something horizontally being done, do the opposite. Vertically, know that because it's already moved over for us, we do it as it looks like. All right. So let's go ahead and get into some problems right now. So first problem is f of x equals x minus 1 quantity squared, minus 6. So first, write out our transformations. So we have a -1 on the inside, undo that by a +1 going right 1, and here we have a -6, so that means we're going to do what it says, go down 6. So if you want, you can go ahead and draw in the original graph. So a quadratic right here if you want to. And then we always go off of that key point, that 0, 0. So we're going to move that key point right 1 and down 6. So this is now our key point. Now those other table values help you because you know this point right here, we went over 1, up 1. So from that key point, that new vertex, we're going to go over 1, up 1. Over 1, up 1. That gives us our new graph. All right. Just a rough sketch. If you want to put in another point, that second one, you could do that as well, but this is our final graph right here. I'll draw that in blue so everyone can see that. All right. Let's go over to number 2 here. We have negative absolute value of x plus 4. And then add 2 to that. All right, so let's write out our transformations. We have plus 4. When we're dealing on the inside, right next to the x, we have to undo that. So that would be a negative 4. Negative 4 is really just like moving left 4. We have a plus 2, so do what it says, up 2. And then we have a negative on the outside of our function. Negatives mean we have to reflect. Outside of our function means vertical. So we're going to vertically reflect this. Okay? So if you want, draw on your original graph. Looks something like this. The absolute value goes through the, it's like a diagonal in your coordinate grid. So it goes through 1, 1, 2, 2, 3, 3, so on and so forth. All right, so we're going to look at this key point and move it accordingly. So we're going to go left 4, 1, 2, 3, 4, and we're going to go up 2. And same thing, make sure you know that table of values. Our first value went over 1, up 1, over 1, up 1, over 1, up 1. So it's going to look something like this. So we did the translating part, now we have to do the reflection part. If we're reflecting something vertically, we're going to take it and we're going to flip it down in this case. So whenever we're doing a reflection, it goes through that key point. So this key point isn't involved in the reflection at all. Everything else is. So our points that we know from our table of values are just going to flip over this line. So we went over 1, up 1 from our vertex. Now we're going to go over 1, down 1. Over 1, down 1. And just draw in that graph. So that is our final transformed graph. So just drawing that in blue and dark so you see the final result right there. It's a good idea to do this in steps so then you can see what each transformation does, and it also helps you to know which ones you already did and ones that you didn't do twice. So if you want to think about it like that, drawing a few more sketches along the way does help. Okay, so let's look at this next one. We have the quantity negative x plus 1 cubed minus 2. Whenever we see a negative inside by the x, we want to factor that out. So let's rewrite this equation by factoring out this negative x. By factoring out, I don't mean outside of this cubed part, I just mean outside of the x and the plus 1 part. So this is really, that's the same parentheses right here. Factoring out my negative, take out the negative from the negative x, I'm just going to have a positive x. Take out the negative from a positive 1, that's a negative 1 now. Now I'm closing the parenthesis, giving it the cubed minus 2. So if I distribute this negative all the way through, I should get this back out. So if you can see that, good. If you cannot see that, we should talk about that in class, so bring that up. All right, now write out our transformations. We have a minus 1 in by the x, so undo that. That means positive 1, right 1. Negative 2 on the outside, so that does what it says, down 2. We have a negative inside by our x, inside the cubed part, so that means horizontal. Inside is horizontal. So we're going to do a horizontal reflection. So reflect horizontally. All right, so for me, I always draw in my basic function first. A cubic looks like this, goes through 0, 0, and 1, 1, and negative 1, negative 1. Okay, next I want to go off that key point, move it right 1 and down 2, so right 1, down 1, 2. Notice that from my table of values, I always go over 1, up 1, and over 1, down 1. So drawing in that intermediate sketch, if you want to call it like that, goes something like this. Okay, and now we want to reflect horizontally. So if reflecting horizontally, that means our reflection line is going to be vertical. And it always goes through that key point, that 0, 0 in this case, or it was 0, 0 what it started out with. And we're going to reflect every point we know over here onto the other side of that line. Every point we know over here to the other side of that line. So we knew this one point was over 1, up 1, which originally was positive 1 as a coordinate. So I'm going to go over 1, up 1. That's what I did. Now I'm going to go to the left 1, up 1. Here I went to the left 1, down 1, reflected over that line, go right 1, down 1. Alright, and that's all of our transformations, so I'm just going to draw that in right now. And now we are done. I'm sketching that in a little bit darker so you can see that. The left end goes up and the right end is now going down. Alright, last one on this page. We got 2 more after this. Looking at this equation, we don't see any negative in by the x, so we don't have to rewrite it, which is nice. We just have to list out the transformations. So we have a negative 1 on the inside, undo that by a positive 3, so that means going to the right 3. We have a positive 1 on the outside, so do what it says, up 1. We have a negative 2, and that's on the outside of our function. Our function is the square root. So if it's outside, if we want to think about, just the 2 part, the 2 means a stretch or a shrink. Because that number is bigger than 1, it's going to be a stretch. So it's outside, so it's vertical. It's bigger than 1, so it's a stretch, and we're stretching it by 2. Okay? And then lastly, we have this negative on the outside. Outside always means vertical, and negative means reflection. So we're going to vertically reflect this graph. So this graph originally looks like this: 0, 0, 1, 1, 4, 2, and that looks like all that's going to fit on my grid that I have right here. Okay? Now that's my original. I want to take that key point, move it right 3 and up 1. So 1, 2, 3, 1. Now each of these points on my table are going to go right 3 and up 1 as well. So I can go right, I can move these right 3 and up 1, so 1, 2, 3, up 1. So it appears to be right there. Or I can go based off of how I did it from this original key point. I went over 1, up 1, over 1, up 1. So it's going to be right there. For this second point, I went over 4, up 2. So from this new key point, I'm going to go over 4, 1, 2, 3, 4, up 2. Something like that. So you can go off of the key point by going over 1, up 1, over 1, up 1, or you can just apply this translation to every single point. It's up to you. Then we want to vertically stretch it by 2. So remember, the key point is not affected by this, but everything else is going to get twice as far from it. So this one was vertically 1 from it, now it's going to be vertically 2 from it. This point right here was vertically 2 from it, so it's going to be vertically 4 from it now. So it looks something like this. Okay. And lastly, we're going to go ahead and reflect it vertically. Vertically, we're going to flip it down, is what that means. And that reflection line is going to go always through our key point, and every other point is going to be reflected over that. So right now, this point, we went over 1, up 2. Now I'm going to go over 1, down 2. 1, 2. Now notice I'm going down 2 from that point. I'm not going down 2 from the x-axis. So down 2 from that point. Then we're going to have to go to the next key point, which was up here. That was over 4 from this. So 1, 2, 3, 4. And it was up 4 from that key point, so I'm going to go down 4 from that key point. So 1, 2, 3, 4. and draw that in. Missed my point a little bit there. And just drawing that in a little bit darker shows you that function right there. All right. So remember, when you're stretching, doesn't affect the key point. When you're reflecting, doesn't affect the key point. It always stayed right there. All right. Now let's move on to our last two. These are the doozies. They involve everything. So looking at number 5, we have negative 2x plus 1 squared minus 3. Notice that there's a negative and there's a number by that x. So let's go ahead and take that out. Rewrite our equation. So taking out a negative 2x, or excuse me, negative 2 from the negative 2x, we have negative 2. The x is right there. Take out a negative 2 from positive 1, you're going to be left with 1/2 squared minus 3. Oops, forgot one parenthesis there. Alright, so notice if you distribute that negative 2 through, you're going to get out the same equation again. Alright, so let's write out all of our transformations. We have negative 1/2, so that means we're going to go undo that by going positive 1/2, which is right 1/2. We have a negative 3, which means down, down 3. We have a negative 2 on the inside, so that negative means we're going to reflect horizontally. So horizontal reflection. And here we have a 2. Remember, on the inside, anything by the x, anything that's horizontal, you do the opposite. So that's a 2, which we would normally think stretches it by 2. It's actually going to shrink it by 1/2. And that is a horizontal shrink. Okay? So let's draw on our original function. Something like that. We have right 1/2, down 3. So right 1/2, down 3. Something right there. And now my points look like this. So this first point is at the coordinate 1/2 negative 2. If you're wondering what that is, that's 1/2 negative 2. Over here it's negative 1/2 negative 2. Alright, so we did these two. Next we will horizontally reflect it. So if you want to reflect something horizontally, we're going to be flipping it right or left. So it always goes through that key point, which is right there at x equals 1/2. Reflecting it, so here we go over 1 from that point and up 1. So this is now going to go left 1, up 1, which makes it land right on the other point. If we look at this point, go over 1, up 1. Now let's go to the right 1, up 1 to reflect it. Oh, it lands on that point. Notice that this is already reflected horizontally. It stays the exact same. So that step is done. Lastly, we just have to shrink it by 1/2. So remember, key point isn't affected, but the distance from it to the next point has to decrease by 1/2. So this one was over 1, up 1. Now we have to go over 1/2, up 1. So we're at the point 1, negative 2. Here, go over 1, up 1, but now we have to go over 1/2, up 1. Now we're at the point 0, negative 2. And that finishes all of our transformations, so we are done. So this graph is skinnier than all the rest of them, and shifted to the right and down. Alright, everything goes off that key point. Alright, last one. We have negative quantity 1/3 times x minus 4 cubed plus 1. So write out our transformations, because this 1/3 is already away from the x, so we don't have to do anything with that. It's already taken out, so we just have to write out our transformations. So we have a minus 4, undo it, add 4, so we're going to go right 4. We have a plus 1 on the outside, so do what it says, up 1. We have a 1/3 on the inside, so that means horizontal. Stretch or shrink, but remember, we do the opposite when it's on the inside with that horizontal stuff. So instead of shrinking it by a third, we're going to stretch it by 3. To undo the 1/3, you multiply by 3. To undo the 2, where you're going to multiply by 1/2. It's that undoing thing when you're on the inside horizontally. And then lastly, we have this negative on the outside, so that's a vertical reflection. All right, draw on your original graph if you like doing that, like I do. Then we want to move that key point, so we're going to go right 4, 1, 2, 3, 4, and up 1. Redraw that if you like to do so. All right, we want to stretch it horizontally by 3. So if this point is our key point, to get to the next point that we actually plotted was over 1, up 1. Now if you want to horizontally stretch it by 3, instead of going over 1, up 3, you're going to go over 3 times that. Over 1, 2, 3, up 1. Over 1, 2, 3, down 1. So now your graph looks like this. It's very elongated, stretched out a lot. And now we want to reflect it vertically. So vertically, we're going to flip this one down. So it goes through that key point that reflection line is. So here we went over 3, up 1. We're going to go over 3, down 1. We went over 3. Oops, excuse me. This point should have been right here. I went down too many. So we should have gone, we went over 3, up 1, so we're going to go over 3, down 1, over 3, down 1, over 3, up 1. So our final graph should look something like this. Alright, so drawing that in with my blue pen just to make it a little bit more distinct. Looks something like this. Alright, so that graph is all done. Just remember, when you're doing stuff horizontally, you have to undo it, do the opposite. And everything goes off that key point. Alright, sorry for the length of this video, but there's a lot of stuff to it and I wanted to make sure I explained all of my work. So I apologize for that. Otherwise, I'll see you in class.